So Unit 1 of our textbook is about atomic structure, and I'm going to kind of divide this unit into a couple of short sections. The first section, atomic structure, we're going to talk a little bit about atoms. Before we talk about atoms, we're going to talk a little bit about the sources of electricity, or the two types of electricity we're going to focus our time on. The first one is direct current. And direct current is unidirectional, which means the electrons only flow in one direction. And alternating current is bidirectional. And this means that it reverses the directions the electrons flow at regular intervals. So if we were to think about a DC source, the electrons, they're going to travel obviously in one direction. If we're looking at an AC source, our electrons are going to go back and forth on the same conductor. So at this time it's a good time to kind of introduce a couple of sources of electricity. The first one up here, obviously, this is a photovoltaic source. So we're taking the energy from the sun and we're going to use that energy which hits the panel, and we're going to force those electrons, there's my electrons, to start to move. And we do that through the power of the sunshine. A second source right here, you can see these are batteries. Batteries are a really good source for DC. And it's important to also talk about batteries because they're used a lot, definitely in the alternative side of things, but these are configured differently. We're looking at a configuration of parallel and also series, and so that we jump into that much later on in the lessons and in the class. But batteries are here, and of course batteries are a chemical reaction, so we need to have something react, something happen inside the battery again in order to get these electrons to flow. Here's a couple basic alternating sources. Many of you are probably familiar with one of these guys here. What do? You pour gasoline, of course, into here. You pull this starter rope, the internal combustion motor runs, and then you're able to come along with your extension cord and plug your extension cord in, and you have the ability to use power tools in remote locations. And that item, of course, is called a generator. And all of these items I have here on this slide are generators. We can use an internal combustion engine to spin some type of a generator. This one here is a vertical axis windmill. We have the wind blow on a windy day and it turns the rotor, and in here there is a generator. And this picture here is just a large AC electric motor, and if you had some type of means such as a internal combustion motor, you would connect it to some belts, connect the belts to the AC motor, you spin the motor at the correct RPM, and you're going to get a AC voltage out of it. So really any AC motor can act as a generator, or we're going to use a manufactured generator, or we might be using some type of wind device as well to generate electricity. The Greeks discovered electricity about 2,500 years ago, and it kind of started in the static state. So they discovered static electricity, and what the Greeks discovered is that if they took an object and they rubbed another object across it, it would go ahead and attract other items to it. And that first item that they used was called amber, and that word amber was spelled electron in the Greek language, and so to be like amber meant to be electric, and so that is how the term electric and the term electron came about. It's a Greek word, and it was named for the substance amber, and that is how the early Greeks created static electricity and began to attract items to that item of amber. Now we fast forward a little ways to Benjamin Franklin here in the United States. He was the person who finally named the items from the list that other folks had discovered that either attracted or repulsed each other. And this was the standard for determining if an object was charged positive or negative. So Benjamin Franklin began the process of determining which items are positive and which items are going to be labeled negative. And obviously when we talk about positive and negative, we're looking at DC sources of electricity, and those terms are still with us today. Here is that list of items that Ben Franklin worked with, and if we were to draw these out in two columns, and if you were to imagine each of them were a ball hanging by a string, you would see that items on list A would want to go towards items on list B, and items on list B would also want to make their way to items on list A. And so what would happen is we would have to redraw our picture, and it would look much like this. If you were to use the analogy of a couple of magnets, you would have one magnet attracting to another secondary magnet. So I've got two photographs on this slide. We're talking about atoms in this slide, and the atom is the basic building block of the universe. All matter is made from some combination of atoms. And then we have this term an element. It's a substance that cannot be divided into two or more simpler substances, and an atom is the simplest part of an element. So you're always going to have atoms which are going to make up elements, and so the atom is the kind of the starting point or the building block of the universe where all things begin. And it's important to understand how those atoms are set up. Oftentimes we think about the center of an atom, and then we have this path that travels around, and on that path we could see these electrons traveling around. And of course my picture is very simplistic. You can also see a little more advanced picture here. However, this photo up here is kind of the most advanced, the way that scientists like to think about this now in a new way. And the reason being is because this vision or this version of this orbit just being a round or an elliptical orbit is not necessarily true. If you actually think about how this is drawn, the electrons could be at any moment, any place within this shaded area, and so it's really not predictable, the orbit, but it's very random in how these electrons can move around that nucleus. A little bit about the nucleus. Here in the center we have these items called protons, and we have neutrons. Those are at the center of the atom, and then of course the things we're really interested in are the electrons, and those are what move around the outside of the nucleus. So the protons, the neutrons, they're the center point, and the electrons move around, And it's also important to know that the number of protons that an element has is equal to or describes the type of element that we have. So for example, I drew a nucleus here with 2 protons. It has 2 neutrons, and I will also draw the number of electrons it has as well. So I would have the electrons, and these green dots represent the electrons, and so this would tell me that this element right here is an element of helium because of the 2 protons that I am seeing inside of the nucleus. So the 3 parts of the atom: the electron, neutron, and the proton. And then of course the nucleus here is a combination of the neutrons and the protons, and the kind of element, or the name of the element which they make up, is determined by the number of protons and neutrons contained inside of the nucleus. And of course the important thing to remember about the electron is it always orbits the nucleus, and it isn't necessarily going in a circular orbit. It's more unpredictable and varied, and so it looks more like that. And so that's why that last picture we looked at in the last slide, it was kind of a shaded item. Here's the last slide of this video. Again, we were looking at the different parts of the carbon atom. We've got the protons are charged positively. We've got the electrons, which are charged negatively, and then the neutron has no charge. So the neutron does not have any charge, and the 2 combine together, protons, neutrons combine together in the center, and because we have 1, 2, 3, 4 protons, we have a carbon atom.